think I believe that I actually said that we would talk about the last couple in class. I really didn't put the answers in there. Okay. Warning. You're gonna hate some of them, but that's okay. That's the way it goes sometimes. Just to give you a heads up. Okay, we don't take a mid-chapter 2 test. We only do one test in all of chapter 2. So if you're looking ahead, which I know a lot of you will, we'll do 2.3 next week. We'll review, but we're not reviewing for an exam. We need the extra practice. We only take one test at the end of chapter 2. So you're not going to have an exam next week. Okay, just keep that in the back of your mind. Okay, cool. In general, okay, let's talk homework stuff. Okay, always pay careful attention to the directions to see if they tell you what to do. Okay, sometimes they'll tell you to describe or draw, or you get to pick. They didn't really tell you in the first one. They just said find a pattern and use it to show the next 2 terms. So you could have just listed the numbers. You didn't have to explain the pattern. You kind of had to draw this one. You know what I'm saying? I guess. Okay. How would you describe this to somebody though if I forced you to describe it in words? It's kind of weird. Kim?
It's a 999 square that with each for the addition of the pattern, the empty slot moves around the perimeter.
So it's a 3 by 3 square, but you remove one of them,
Yeah,
right?
like
Yeah, you said that. That's okay.
$9.99.
I got you. And then we're moving this piece. Do you even still know the terms clockwise? Is that still a thing?
Yeah.
One day it will be. Okay. Pretty good. Okay. So hopefully those ones were okay. How did the counting go of the sequences and everything? For the cycle. I think some of you weren't convinced by that one. Okay. So cool. Okay. It should have been okay. Like this one. This is what I mean. Okay. So you just kind of want to count the cycle. So circle, triangle, square, star. Circle, triangle, square, star. So in terms of the shape, it's a 4 cycle. And then the color, what is it? Gray, white, black, that's 3. So for the color, I divided by 3 because every 3 the cycle is over. And I divided by 4 for what shape, for what kind it is. Okay, so does that logic kind of make sense a little bit? Some of you weren't convinced when we did that one in class. What's up?
Yes, I did that, but for the color, I just also divided it by 4 and I still got black.
You might. Yeah, you might. Just be careful because it might not always align that way. Okay? And reminder, this 25, all it means is 25 even cycles with no remainder. And remainder 3, it means complete cycles and then just go 3 in. Okay? Cool. Okay, so these. I didn't post answers to these. I want you to quick have a conversation with somebody about what did you think the patterns were. And if you don't know what they are, see if you can figure them out now.
Don't say it.
For all of them. A little bit.
I've seen that one. I just
Let's talk about the first one. Okay, and yes, these patterns are different. Okay, starts with what the next number is. I think they ask you just for the next term. Name it if they know the next term. Catherine.
61.
61 is the winner. Okay. What's the pattern, Catherine? How would you describe it to somebody?
So you flip the numbers backward and then you take the square root.
Okay. So this is 9 squared, but backwards. This is 8 squared, but backwards. And then it just keeps going down. 7 squared, but backwards. 6, 5. Okay, this is 4 squared, but backwards. How many of you found that one? I kind of figured some of you would have found that.
How do you even think to do that?
That has got to be
Magic. You listen to the Nifty United States songs 100 times and things like that pop into your head. Okay? All right, cool. 61's a winner. Same head, next one. Okay, next one. Ellie.
They're the first letters.
Oh, I just won the next number. Next letter, sorry. T. Yeah, and what are they? Just tell me.
The first letters of 1, 2, 3.
1, 2, 3, 4, 8. 9, and 10. Like I'm getting wise. Okay, pretty good. Okay, anybody find that one? Ooh, a couple of you did. I don't know. Sometimes it just hits you, sometimes it doesn't. Okay, that one's pretty good. Okay, how about the next one? Next one. Oh, more hands for this one. Okay, Kennedy.
So it's like
What's the number? Sorry, what's the number first?
64.
Okay, 64. Go ahead.
So like it's like you take the first number, it's like 1, and then the next number would be 2, but like squared.
Mm-hmm. And then
3 and then 4.
then 3 and then 4 squared, 5 and then 6 squared. Then 8 squared. Okay, pretty good. Okay, and the last one. Last one's kind of silly. Okay, Marissa.
X, Y, and Z are at the top, but it depends on the formula.
Okay, but they technically have built off the line. Okay, and why would you say that?
Because the lines like have like curves on the bottom.
Yeah, these are all curved letters. They have some kind of curve in them.
This doesn't even have anything to do with
I know.
Like what goes through your head? So you're just like.
I don't want to know what goes through your heads, okay? I wouldn't stress about those. They're just trying to get you thinking a little bit. Did anybody get at least one of the 4? At least. Did anybody go 0 for 4? Hey.
How do you
sorry.
manage to?
I don't know. Okay, I got one
Too
that's.
busy watching Thursday Night Football.
I got one that's worse. If we have time, I'll put it up later. I might save it. I might save it. Okay. Okay. 3 questions. I want you to answer true or false. Quickly talk about them with somebody. It was a good game. That was a legit game.
So bad. It's gonna be lit.
You can't hit the like. I thought the punter call was like he hit him. Like you can't do that. And then that interception was bad. It was a good game.
They should just trade
We can talk about that later. I have different thoughts about it than I did before that game.
Are we
If it's false, provide a counter example. That's coming today.
Did you get false?
Any counter example if you say false. In time, okay? Yeah, you should be good, okay? So, the true statement, okay, it actually starts, I don't know how many of you skipped past this, but you shouldn't have, but if you jumped right to here, let's backtrack. Given the true statement, if an integer is a multiple of 8, then it is a multiple of 2. That is 100% true. Okay, the red statement up there. I don't know if anybody remembers what I called that yesterday. It was a conditional. Conditionals are if-then. Okay? If-thens are all around, especially in mathematics. That's true, but then we break it down a little bit more. If an integer is a multiple of 2, then it's a multiple of 8. What did you all say? Okay. What examples could you say? I heard 4. No. Okay. Plenty of examples. And remember we said yesterday, you only ever need one counter example. One counter example ruins it all. Okay, number 2, if an integer is not a multiple of 8, then it is not a multiple of 2. What did you say for that? Counter example? 8? 8 is a multiple of 8. Okay?
100.
6 is not a multiple of 8, but it is a multiple of 2. Easy one. Okay? Then the last one, if an integer is not a multiple of 2, then it is not a multiple of 8. That one's true. I want you to notice what they did with the statement. They basically took the statement, they flipped it, they made it the negation of it. That's the stuff we're going to talk about today. Okay? It's doable, but it's a little bit different. Okay? So we're going to talk about the converse. I'm sure you've all heard of converse issues. Have any of you heard of converse in mathematics? Okay, cool. Well, guess what? That's what we're going to get to. Okay? Cool. Okay, so let's talk about these statements, okay? Okay, and then you're going to start to get what the converse is. You're going to tell me after filling these in. So the statement, if I study, then I pass the geometry test. Which the test started to look a little bit better when I got a little deeper into them yesterday. Converse, if I pass the geometry test, then what do you think? Than what my parents made. Yeah, okay, no, that's not what it is. Okay. What do you think the converse is then? I studied. Good. I haven't really told you what a converse is yet, but if we can fill these in properly, you'll kind of see what it is. Okay? 5. Statement. If I am happy, then I laugh. Converse. If blank, then I am happy.
I laugh.
Haha.
I get it now.
So the last one, statement. If I have a summer job, then I can buy a new phone. What do you think the entire converse is? Very good. So without even looking at the definition, how would you describe the converse to somebody? Layla. Reverse. Yeah, okay. I actually was going to say somebody could just do this. There's a difference between the opposite and the reverse. Okay, Caleb, question.
Does converse have to be true?
Nope, we're going to talk about all that stuff today. It does not have to be true. You actually saw that already. Okay, notice what Layla said, and then we fixed it. She fixed it quickly. She didn't say the opposite, because that's when not comes in. She said the reverse. And then Conlon did this. This is actually the same symbol I do to people. You're switching it just like that. Yeah. Okay, and then Caleb asked the question we're going to look at today. Converse doesn't have to be true. Okay, in fact, okay, we looked at a breakdown here. If an integer is a multiple of 8, then it's a multiple of 2. We actually started flipping it around, and then we had different true and different false values. Okay, cool. So what's this ad implying? Louis.
If you save money, you live better.
That's a conditional, right? Is that true?
Yes.
Totally depends on your definition of living better, I would say, so to speak. Okay? What would the flip of it be? Go ahead, say it.
Live better, save
If you live better, you save money. Could that be true? I mean, I don't know, okay? These are conditionals. They're actually all around you, okay? And you might think of the conditional different than the converse. So if the statement is, if you save money, you will live better, which is, there's no way to say that that's true or false. It's very ambiguous. The converse is a very different statement. If you live better, then you're going to save money. Actually, some people might argue the opposite of that. If you live better, you're probably using your money on things. So there's no way to evaluate if those are true or not. Okay, but flipping them around, I think, is kind of interesting. Okay, that actually leads to your definitions, and this is on the next page. A conditional is an if-then statement. Okay, it's broken down into 2 parts. Those 2 parts are the hypothesis and the conclusion. Okay. I don't think you need to write any of this. I think this is all in the chart beneath you, okay? Isn't it? Yeah. A conditional is an if-then statement. The hypothesis is the part P following if, and the conclusion is the part following then. So there's words, and then there's the symbols, okay? The PQ symbols, which you will get very used to these, like pretty quickly. Anybody that's ever taken geometry, if you know a friend or a sibling, whatever, they remember the PQ stuff, hopefully. Okay, so here's how you read a conditional. How do they tell you read this? If P, then Q. That's what this means. The other way to say it is P implies Q. Okay? This is my hypothesis. What's this? Conclusion. Okay? Conclusion. Okay, hypothesis, then conclusion. So if P, then Q. Okay, and then we have to decide if things are true or not. But that's what a conditional is. Okay, so some conditionals. Things you might see. Reasonably true? Reasonably. You might not know about the first one. Notice they're all if-then. If-then statements, okay? I mean, obviously, right? You don't think this is a true conditional?
I think this is true.
Yeah? I have others. One of my favorites. I mean, really, think about it. If it's such a perfect fit, how is she rolling around without that? Okay? I'm not sure if anybody's ever seen this one. I remember seeing this one when I was much younger. Because what is it normally? If at first you don't succeed, try again. A whole different take on that. All conditions, okay? So being able to identify these is kind of critical. It says identify the hypothesis and the conclusion. I'm going to use different colors, Okay, the other thing you can do is you can underline it and you can put P and Q by it. If two lines intersect, then they intersect in exactly one point. Okay, let's see, Ronan, what's the hypothesis?
The hypothesis is if two lines intersect.
Actually, it's not quite that. It's actually, yep, but you have the right part. We don't underline the if. Okay, the if is part of the conditional. Okay, then they intersect in exactly one point. How about a conclusion, Sarah? Okay. Now, we don't have to get into this now, but it's going to come up in a little bit. We have to decide, is the conditional true? And then what if we started messing around with it? Okay, but right now we're just identifying. Okay, Moxley, two lines are coplanar if they are parallel. Okay, why don't you give me the hypothesis first?
Two lines are coplanar.
Nope.
There.
Terry.
They are parallel.
Ooh, see, Terry. Okay. Nobody said the hypothesis had to come first. Remember, the hypothesis comes after if. So here they're actually giving you the conclusion first. What's the conclusion, everybody? Yeah. Okay. Sneaky. You just have to think to yourself, what is the hypothesis? What's the conclusion? I actually usually find the conclusion first. But what is your clue there? If. Okay, if is your big clue. That's how you can decide where it's going to go. Okay? Cool. So I want you to write each of these as a conditional. Okay, I want you to talk about them together. Write each of these as a conditional. This is why some of you are going to hate chapter 2 because there's no way around it.
Like if a figure has 4 right angles, is an angle. Yes. If we just write equal, these are angles.
I'd be ready to write more too because I think some of you will see. Best thing you can do in chapter 2 is just acknowledge you can't get away without writing and things. Actually, you can do the dog one too. There's 3 of them. Go ahead and do the dog one too.
Is it if an angle has a measure of less than 90?
Like, the dog, like all beagles are dogs.
That's what you're trying to decide, yeah.
If a dog
Every table I can hear, if it's a dog, if it's a beagle. The beagle one's fun because people actually get into arguments about it. You know what a beagle looks like? Beagles. Beagles.
That was AI.
Snoopy is a beagle, correct.
I like chihuahuas. I like chihuahuas.
I think Snoopy is a beagle. I mean, he is. Funny. Okay, now, there's a reason I threw the beagle one at you. Because the beagle one, besides people getting to talk about it, only has one answer. There's only one statement you could have written for the beagle one. That is not the case for these. In fact, guess how many statements each of these could be? 3, 2, okay, 1. A lot of you are going to have to fill in. I didn't ask you to write 2, but you're going to write 2 in a second. A rectangle has 4 right angles. We know that that's true. So we have, maybe you wrote this one. If a quadrilateral is a rectangle, then it has 4 right angles. Anybody write that one? You gotta adjust it to quadrilateral. You'll see why later. The other one you could write, if a quadrilateral has 4 right angles, then it's a rectangle. That one might be more popular. Do they both work? Okay. Now you already see the adjustment you had to make. If you wrote polygon, figure, you have to adjust it to quadrilateral. You will see why. There's an easy counterexample that will come up. Yes? Yeah, exactly. Exactly. We'll show it. Okay? They need to be those and those exactly. Most of you might have something. You might need to tweak it a little bit. I feel like a lot of you just wrote 1. Okay? Good. So, let's talk about the angle measure one. Again, I'm going to show 2 of them. But this is inherently true. An acute angle measures less than 90. Okay? So I wrote, if an angle is acute, then it measures less than 90. Anybody write that one? That's probably one of the more popular ones. Nobody. What would the other one be? Okay, that would be your other one. If an angle, did anybody write that one? Okay, good. All right, so that's fine. I'm not saying one is more obvious than the other. You might have just thought to only write one, but you do need both of them. There's a reason you need both of them, and we'll talk about that soon. Question. It has to be that. They have to be that. They have to, Taylor, they have to be that. I said that like very clearly. They have to be that. No variations. Okay? There's a reason I need you to get both of them. You will see why. So then you look at these 2, and then we talk about the Beagle one. They didn't give you a statement. They gave you this little diagram. Okay? There are not 2 answers to this one. In fact, there's only 1 answer. Okay? Sari, what is the only answer to the Beagle one?
I always say that if it's a beagle and it's a dog.
That's the only one you can write. Alex, no. No. You can't write the other one because what would the other statement be? If an animal is a dog, that's not true. Anybody here have a dog that's not a beagle? There you go. Counterexamples all over. I have 2 of them. Okay? So the diagram's kind of interesting, okay, because this is more specific and only works in one direction. These, okay, you had to write both of them. Okay, we're going to get into that in a little bit. Any questions about any of those? Okay, cool. That leads to the official definition of converse, okay? Converse, a statement that switches the hypothesis and conclusion of a conditional. We will be looking around for anybody wearing Converses for this entire chapter. I do not. Why are you bleeding?
No, this one's about to fall down.
I do not. You gonna be all right? Can you power through it?
Yeah.
Tough. It's tough. Okay, and again, earlier Caleb asked the question, which is good, and we're going to start getting into it. Does the converse have to be true? No. It can be, doesn't have to be. And notice yet again, too, we're clarifying what Layla said earlier. It's not the negation. She changed it. It's the switch. You're literally just switching the hypothesis and the conclusion. Then you're trying to decide, okay, if that's the case. Okay, if it's true or not. Okay, now in doing so, you're also going to find the truth value. The truth value is simply true or false. That's it. Conditionals and converses, and the other 2 that we'll get into, are either true or they're false. That's it. There's no sometimes. It's like, yes, this is true, or it's false. Okay? So we're going to write the converse and then determine the truth value of each statement. If it's false, we're going to provide a counter example. Okay? So the statement given is, if a month has 28 days, then it is February. Let's write the converse first. We're just going to flip them. What would it be, Layla? Okay, there's your converse. If a month is February, then it has 28 days. Just flip it. Perfect. Again, if you can't remember that, just remember Conrad over there. He's doing this. Right?
Conrad Converse.
Oh. Just Converse. Okay. Truth value of each of them. We'll go to Connie. The original statement. If a month has 28 days, then it is February. Is that true or false, Connie?
False.
Yeah, give me a counterexample. Literally any other month. All the months have 28 days. They all say 28. You can't have 30 or 31 without also having 28 along the way. Yeah, okay? Converse. If a month is February, then it has 28 days. True. Leap year's got 29. Still has 28. You do need to assess that, okay? Now, if a statement is true, you don't need to back it. This is like going to help you with some work. If it's true, you can just say it's true and move on. If it's false, you have to provide a counterexample, which we talked about a little bit yesterday. Okay? Are we all good on the true false there for those? Yes? Okay? Cool. How about this? If x squared is greater than or equal to 0, then x is greater than or equal to 0. Okay, let's start with just by writing the converse. So that's the statement. Okay, the converse, we're just going to flip them. So talk to me, everybody. If what? Okay, now I want you to talk about your table, just the truth value of each of these. Is this true? Is this true? There's a graph if you need it, by the way. There's x squared. And you have to evaluate them separately. Hey, if you don't agree with people, put down your own answers. You have to evaluate these separately, though. You can't just do one. You have to do the truth value of this and the truth value of this. And I have a graph up there of x squared if you need to see it. If you need to see a graph, it's up there. Okay, let's see here. Eddie, the original statement. If x squared is greater than or equal to 0, then x is greater than or equal to 0. What did you say? True, false?
False.
Counter? What was your counter? Okay. Do we all agree that negatives will work? Look at the graph. If you don't believe me, that's x squared. It's positive for all of these values except for 0. Okay? If x, the converse, if x is greater than or equal to 0, then x squared is greater than or equal to 0. What is that, everybody? True. And remember, you do not need to justify your true conditionals. It's true because it's true. Okay? I wouldn't waste my time. I would make sure it's right. You have to provide at least a counterexample for the falses. Okay? Try one more. Try this one as a group. Okay? You're supposed to write the converse and then evaluate true or false. Okay? The divisible by 3 one. Go ahead. Try that one. I'd write the converse first.
And then the converse is also. What about 9 is The converse is also. The converse is the sum of the digits.
I got that one right then.
What are you laughing Oh my.
You like that?
Yeah, that's really good.
Very AI.
I thought so too. Okay. Yeah.
Wait, the middle one doesn't have ears.
To see if it's divisible by 3. Like this one. Okay. So, reminder. This isn't required, but my advice, and I give you advice. I typically label the statement S and then at least the converse C. Now that's going to get more complicated in a minute because there's more than just the converse, but it does help. Okay? You can't get lazy on me. If I ask you to write the converse, we're just asking you to flip. That's free points as long as you know what you're doing. Can't take shortcuts, okay? Statement, if a number is divisible by 3, then the sum of its digits is also divisible by 3. Is that true? False? It's actually true. Ask Layla. She apparently does it to every number she comes across. She just adds them up. Okay, that does work. The converse, if the sum of a number's digits are divisible by 3, then the number itself is divisible by 3. Also true. We're not going to get into this till Monday, but does anybody know what it's called when a statement's true and its converse is true? Okay.
It's double true.
Not a double truth. That's not a thing. Alex?
Very true.
Nope. Good, nobody knows. Graham? It's called a biconditional. It is true and its converse is true. Obviously, same thing. That'll come on Monday, okay? Now, here's where the fun begins. Let's talk negation. Okay? Negation. And then, yes, you have to get used to this little symbol right here. That is the not symbol. Not. Okay? Has the opposite truth value of the original. Negations are fun, but they get messy because there's a lot of thinking about, is it true? Is its negation true? Is the negation of its converse true? There's a lot to think about. Okay, so there's 4 statements below. I want you to write the negation of those 4 statements together. There's 4 of them. Go ahead. There's 4 of them. Okay?
What's the opposite of Tuesday?
You're going to write the negation of those statements.
What's the opposite of Tuesday?
Like, oh yeah, I'm born right. Oh, like, it's
Yeah, that's so
What?
you spell Tuesday the other way.
No, what is not Tuesday?
It's just add
Oh wait, no, tomorrow. The opposite of yesterday. Wait, I don't get it. No, tomorrow's.
We learned that last week.
No, tomorrow's Wednesday.
My fonts have been bad. Look, can you see? They're like blurry. I know, but still. Okay. Now, you would think, you would think that everybody will get all 4 of these. Some people, they'll try to get cute and they'll get them wrong. I'll show you what I mean, okay? It is raining outside. Prisha, what is the negation? That is the only one you can write. It is not raining outside. You can't get cute and say, oh, it's sunny out. That's not the negation of the statement. That's a different statement. It's also not true. It can be sunny and raining, which I think is one of the weirdest things that's out there. That's your only answer, okay? Jack, today is Tuesday.
Today is not Tuesday.
That's the only one you can write. Thank goodness. I think Tuesdays are actually the worst days of the week. Everybody says they hate Mondays. I actually think Tuesdays are rougher. Sari, question, you want the next one? Let's take the next one, Sari. ABCD is not a convex polygon.
ABCD is a convex.
Yeah, I'm just going to get lazy and write that. I'm just going to cross out the not. Okay? Is. I don't know if anybody remembers, the other kind was concave, but even still, you don't write that. Okay? Then Ellie, the last one. The measure of angle XYZ is greater than 70.
The measure of x, y, is less than 30.
It's actually not the quiet one. Cole,
The measure of XYZ is less than or equal to 7.
that's what she said.
Oh.
That's not the negation. That's just the rest of you know what it is?
Negative 7.
No. Layla? Yeah, looks like this. That's the not greater than 70. Remember, I'm trying to draw a distinction here. Your job is not to tell me all the other possibilities. Your job is to tell me it's not that. Those are very different things. You're not telling me, well, all the other options are this. Like, look at the Tuesday one. You can't tell me today's Monday or Wednesday or Thursday. Like, that's not the job. The job is just negate their statement. Okay? Questions about that? Cool. Okay? That leads to the chart. Okay? I love the chart. I remember this from when I was taking geometry back when I was a kid. Okay? So a conditional, okay, we'll actually come to the example in a moment. We're going to jump right to symbols and how to read it. A conditional looks like this, P to Q, and how do we actually read it? If P, then Q. We've already learned about the converse. Converse, what are we going to do with the symbols? Flip them, so what's it going to look like? Q, arrow P, but how do we read it? Good, we've done those two already. Got it. There's two other ones. I want you to see if as a table you can figure out what they are. It's called the inverse and the contrapositive. And you can use this example. See if you can fill out the symbols and how to read it together. You can use their example if you want. They gave you a good example. You can use this example as a guide. I would use their example as a guide.
Yeah, it is. And then
Be able to
the
think.
bottom one. So it's
I am the inverse.
the bottom is
I'm getting arrow.
If you're struggling, this should help you. Using their example, that's your P and your Q. That's your hypothesis and your conclusion. I know because I can read what we did from earlier. Give you about another minute to check. I know you're just filling these in, but use this as a guide to see what these guys are and how to read it.
Oh wait, no. Yeah, that's that one.
All right. So let's look at their example and the first two. I did identify them correctly. You can tell me if I'm wrong, but this is how we did it. If the measure of angle A is 15, then angle A is acute. That's true, right? What's my hypothesis, or P? Measure of angle A is 15. What's my conclusion? Angle A is acute. P to Q, we're good. They flipped it. If angle A is acute, that's my conclusion, then measure of angle A is 15. That's Q to P. If Q, then P. Okay? So those two do match. I didn't say if they were true or not, at least the second one. The second one's not true. Okay? Anybody think they want to fill in the inverse for me? Okay, the row. This row right here. No one wants to take a stab at it? Marissa? A cross through it? Didn't anybody see the not symbol earlier? What's the not symbol? That. Okay? With a cross through it. That sounds so aggressive. Okay? So how do you want, what are we going to say? You can also just say the word not. Not P to not Q. Let's look at the statement. If the measure of angle A is not 15, that's not P. What is that? Not P. Then angle A is not acute. That's not Q. What is it? Not Q. Not P to not Q. If not P, then not Q. That is called the inverse. The opposite of the hypothesis, conditional to the opposite of the conclusion.
Why are they P and Q?
They've just used P and Q for everything with these logic tables, okay? That's called the inverse. The last one's called the contrapositive, not a term you really see outside of this course. If angle A is not acute, so what is that here? If angle A is not acute, what is it, everybody? Not Q. Then measure of angle A is not equal to 15. Not Q to not P, which our last statement right there. If not Q, then not P. You do need to know these. You don't need to know them now, but you will need to know the difference. Okay, now here's the good news. They don't change. The only thing that changes is the truth value. Okay, so let's think about these as being true or not, because nobody said they all had to be true. The conditional, if the measure of angle A is 15, then angle A is acute. That's true. If angle A is acute, then the measure of angle A equals 15. Not guaranteed, so that's false. If the measure of angle A is not 15, then the angle A is not acute. Yeah. And if angle A is not acute, then the measure of angle A is not 15. So it's not acute, meaning it's not in that range. Therefore, it cannot equal 15. Yeah, good. So, you can have a smattering of true and false depending on the original statement. Okay? You just have to look at them carefully and analyze them. Okay? 8 questions about that table. It's so big for the rest of the chapter. P to Q is always your conditional, and then you can get them. But you do need to know the names. Okay? So keep all that in mind. Okay? So we just checked the truth value. What we checked were equivalent statements. Equivalent statements are any statements that have the same truth value. Remember, truth value just means true or false. Okay, that's all it is. So in this particular chart, the conditional and the contrapositive are equivalent statements. The converse and the inverse are both false, so they have no equivalence. Okay? Cool.
Statements even like different, like not like the conditional converse and inverse, but like two unrelated statements, but they both consider them false.
Unrelated, I can talk to you about that, okay? I want you to, this takes a couple minutes, I want you to work on it together, okay? You're given a conditional, I want you to, as a group, write the converse, the inverse, the contrapositive, and then decide are each of them true or not. Maybe start by reading the conditional first, see what you're getting yourself into. Okay, write them all. Yeah, when we're done with this, I can do whatever you're doing. You can talk about whatever you're asking. I want to get this guy done first.
Wait, don't you say it's a polygon? Just say polygon is a triangle. You can't just
Come on, come on, come on.
Polygon doesn't
Not, lots of knots.
Wait, no, if a polygon does not exactly on both sides, so you have to find the inverse of the ratio.
You just listen around, you hear people yelling, not. And you see the two of them doing whatever it is they're doing back there. Moxley, did you write all of that?
Yeah.
I know this is your kryptonite, but it's like the only way we're going to do it.
Is it true?
Write it all out. And then you have to decide if each of them is true or not. If you finish that one, you can start looking at the job being one at the bottom. That's our last
The
one.
inverse is true.
It is not a triangle, then it's not. Wait, yeah. So straight, the polygon is a triangle. They're both straight. They didn't.
Underneath that, it says if it's Sunday, I'm going to be watching Red Zone for 5 hours. I don't like Red Zone as much as I used
Yeah,
to.
it's not commercial free anymore.
Yeah, I don't care about that.
You root the inverse.
If it is a Sunday, if you jog, it might be on a different day, but you jog every day. So I
There's no
The polygon one. I don't know if anybody did what I did. I tend to label my P and Q. It helps me. I'm not saying you have to, but my P is a polygon has exactly 3 sides. My Q is the polygon is a triangle. So I wrote all 3 of them. Let's start converse. If a polygon is a triangle, then it has exactly 3 sides. Survey says? True. Inverse. This is not P to not Q. If a polygon does not have exactly 3 sides, then it is not a triangle. Also true.
Maybe one box further down than
No. I'm good. Contrapositive. Not Q to not P. If a polygon is not a triangle, then it does not have exactly 3 sides. Clean sweep. They're all true. Including the original statement. Clean sweep. Okay? Good. The last one. Some of you got to look at it. If not, we'll look at it together. Your classmate rewrote the statement, you jog every Sunday, as if you jog. I know. The weighted vests are very popular right now. I'm not sure. I can't. You know how people love the weighted vests? Have you seen these people? There was a girl the other day at the gym. She was wearing a weighted vest and ankle weights. Was she locked in?
Yes.
She was definitely locked in, literally. Okay. Your classmate rewrote the statement, you jog every Sunday, as if you jog, then it is Sunday. Is that right? What's the error, though? Then we can correct it. What's the error? Okay. No one can tell me the error? A couple people. Grace?
because they could jog on days that aren't Sunday, but they jog every Sunday, so it would be, if it's Sunday, then you jog.
They concluded that you only jog on Sundays. Can't make that conclusion. Okay, so they would be around saying if it is a Sunday or if it is Sunday, then you jog. That would be way more accurate. Okay, the first one's assuming that that's the only day that you jog. That's not correct. Could be correct, but we don't actually have that information. The second one is a true conditional. If it is Sunday, then you jog. But not like this guy here. You know, training for, I don't know what you're training for, if that's the case. Cool. Please start looking at this. You did a good job. Okay, this stuff is tricky but doable. Make sure you write things out.
Mr.
I
Nutella.
do, but like the little thing that keeps it on my wrist.
What was the trade?
It was against Josh Jacobs and Allen, but I did Devon H.
Okay. It has
I think he got the better of the trade, but I could be wrong.
Josh Jacobs and Keenan Allen.
That's who he got?
Yeah, he got Josh Jacobs.
I think Keenan Allen's going to have a good year.
Yeah, but he was on my bench. Because I have Vlad McCollum. I was starting him.